This lesson deals with Supplemental Problem 4.4. You can find this problem in the course ebook in the Chapter 4 Supplemental Problems on page 3. Given this circuit with a voltage source, 2 inductors, 2 resistors, and a capacitor, can you find the voltage V of t in steady state? We'll again use our 3-step algorithm to solve problems in the frequency domain and bring the results back in the time domain. So step 1 is to convert the circuit to the frequency domain. My frequency is 500 radians per second. Have a magnitude of 10 and an angle of 0. 12 ohms, 4 ohms stay the same. My inductor is j omega L. This is equal to half of a k. And here's 2 milli. The k's and milli cancel and you just get 1, so it's j1. For the inductor here, it's j omega L, so it's going to be 8 milli times half a k. I get 4. K and millis cancel, so j4 ohms. And then for the capacitor, this is half a milli multiplied by half a k. K's and millis cancel, I get a quarter. The reciprocal of that is 4, so it's a minus j4. Or you can just punch it in your calculator. Step 2 is to do the analysis in the frequency domain. But these two have the same magnitude but the opposite sign, so they cancel. This is called series resonance. Just left it with just 4 ohms. That's in parallel with 12. Product over sum is 48 divided by 16, and that turns out to be 3. The voltage V is a voltage divider with 3 ohms, voltage divided with J1. Because we're doing multiplication and division, let's put everything in polar form. This is 3 at angle 0. Punch this in my calculator. I'm going to get out a magnitude and an angle. The magnitude should be longer than either of these two because it's the hypotenuse, so that's 3.162. That seems reasonable. I should be in the first quadrant. This is shorter than this. If these were equal to each other, I'd have 45 degrees. If this is longer, we're closer to the real axis, and so my angle would be less than 45 degrees in magnitude, and that seems, again, reasonable. Again, it could be wrong, but at least it's in the ballpark. We're going to multiply 10 times 3 and divide it by 3.162. That's a little bit less than 1, so you get 9.487. 0 plus 0, and then minus a plus 18.4. Step 3 is to transform back into the time domain. V of t is going to be the amplitude of 9.487, the cosine of 500t, and then minus 18.4 degrees, and the units are volts. And this is supplemental problem 4.4.